Hi and Assalamualaikum everyone. My name is Adlina from class 18 and today me and my group will be presenting about camera and smartphone lenses. First and foremost, these are the group members of our group. Next, these are our table of contents that we will discuss in this video. For introduction of our topic, cameras and smartphone lenses using optics and wave behavior to capture clear images by refraction as light passes through the lens and focuses on a film or sensor. The wavelength and direction of light waves aid in precise focusing and lens coating lessen glare. The same concepts are used in smartphone cameras, which have software that enhances focus, illumination, and detail. Both phones and conventional cameras can produce high-quality digital photos because to this combination of optics and wave behavior.
The sign behind lens. First, lenses control how light enters the camera. Lenses are the key part of how a camera sees. They control and guide the light into the sensor. Second, made a curved glass or plastic. Most lenses are made from curved glass or plastic to bend light properly. Number 3. Convex lenses focus light onto the sensor. Smartphones use convex lenses which bend light inwards to focus it directly into the camera's sensor. Number 4. Focal length effect, zoom and view. The focal length changes how zoom in or wide the picture looks. Shorter length give wider shots, longer means more zooms. Number 5. Smartphones use multiple small lenses. Today's phone have several small lenses for different modes like wide angle, zoom or portraits. Number 6. Uses software plus AI to enhance photos. Software and AI also help improve images, adjusting brightness, sharpness and removing blur. Number 7. Lenses plus light equal to clear, detailed photos. In short, when lenses and lighting work well together, you get sharp and beautiful pictures. Thank you.
So now I'm going to talk about how smartphone lenses work. The first one is the multiple lens element. So inside a smartphone camera, there isn't just one lens. Actually, there are several tiny lenses made of either glass or plastic. So each one is shaped carefully to bend light in a certain way. This bending of light is called refraction. So the purpose of all these layers is to make sure the light entering the camera is focused correctly onto the image sensor. So without multiple lens element, our photos would be blurry or distorted. So these lenses also help fix color problems, like when colors don't line up properly, that's called chromatic aberration. So even though we don't see them, these tiny lenses are doing a lot of work to make sure our photos are sharp and accurate. The second one is the autofocus mechanism. So you've probably noticed that when you move your phone closer to an object, the camera takes a second to adjust and become clear. That's autofocus at work. So tiny motors inside the photo move the lens forward or backwards to help focus on the object. This process happens really fast. So the camera uses one of the two methods, contrast detection or phase detection. Contrast detection looks at how sharp or blurry the image is and tries to find the best focus. So face detection is faster. It compares light from two angles and calculates where the focus should be. So thanks to autofocus, our photos comes out sharp even if we're moving or taking close-ups. So now let's continue with three more features that work behind the scenes to improve our photos even more. So the third one is the fixed aperture. So most smartphone lenses have something called a fixed aperture. So this means the size of the opening that lets light into the lens does not change. In professional cameras, you can make the opening bigger or smaller to control how much light enters, but in smartphones, it is fixed in one size. So even though it's fixed, it still plays an important role. It affects how bright the photo is and how blurry the background is. So, which this is called depth of field. So, while it's simpler, the fixed aperture helps balance light and focus automatically. Next, for the fourth one is the focal length and lens type. So, every camera length has a specific focal length. This is what controls how zoomed in or zoomed out the picture looks. In smartphones, we have different types of lenses, such as like the wide, ultra wide, and telephoto, which is zoom. So that's why phones now comes with multiple lenses, multiple cameras. Each lens has a different focal length. When you zoom in, the photo switches to the zoom lens. This is called optical zoom, and it keeps the photo quality clear, unlike digital zoom, which can make the image pixelated. Lastly, for the fifth one is the computational photography. So this is where the phone uses software to make the picture look even better. For example, it can automatically adjust brightness, make colors pop, sharpen the image, and even improve low light photos using night mode. It can also combine multiple images into one, like in HDR mode, to get the best lighting and detail. This is especially important because smartphone lenses are small, so the software helps to fill in the gaps and make the photo look like it was taken with a bigger or more expensive camera. So, as we've seen here, smartphone lenses combine tiny mechanical parts, clever optical design, and smart software. Together, all of them allow us to take high quality photos every day, whether it's a selfie, a landscape, or also a night shot.
So now let's get through for the application for this topic. So first of all is photography and videography. So smartphone lenses are designed to capture high quality image and videos. It helps users to preserve everyday moment in clear. So with these features like zoom, wide angle and portrait mode, user can create content for social media, events and personal memories. These lenses are essential tools for selfies, blog and creative projects. Other than that, it's for communications. So, smartphone lenses play a key role in enabling video calls. They let people see and talk each other in real time, which is important for online meeting, visual learning, and staying connected with the loved one. No matter the distance, users can maintain a visual communication, making conversations more personal and effective. Moreover, we have augmented reality or requires a AR, so smartphone lenses are crucial in AR experience. They continuously scan the environment to detect objects, calculate distance, and track motions. This allows AR apps to place digital items into a real world, like games, educational tools, or navigation apps. Some phones even use extra sensors like LiDAR to improve accuracies.
Lastly, to
After
conclude,
that, we
the
have
lenses
security
on
and
cameras and
monitoring.
smartphones
Usually
use
we know
fundamental
as the
optical
iPhone we have
principles such as
Update ID,
refraction,
for example.
light with
The
behavior,
modern
and
phone
image
uses
focusing
lenses
to produce
for
sharp and
facial
detailed
recognition
images.
to unlock device
Lenses are
securely.
essential to
This
modern life
ensures
from
only the
communication
owner
and
can access
security
the phone.
to
They
photography
also
and
used to
videography. These
identify
features
their
promote a greater
verifications,
understanding
secure
of how
payments, and
technology
monitoring
functions
system,
and highlight
making
the importance
smartphone
of
not just
physics
a communication
invention.
tool but also
This
a
will
personal
lead to better
security
understanding the
devices.
amazing interaction between science
Hi,
and
my name
ordinary
is Iman.
experiences
So now
by
I'm going to
approaching
talk about real life
technologies from a
demonstration.
scientific perspective.
Okay, the DIY lens setup. A magnifying glass as a lens was used. Okay, so basically a magnifying glass is a convex lens. It's the same type of lens that can be found in camera and smartphone optics. So for the apparatus and materials, a magnifying glass was used. So it basically acts as convex lens. Next, torchlight acts as light source. Next, object acts as small tree. Lastly, paper acts as white screen. Okay, so light will reflect off any point of a surface and travel in many directions. If you put a convex lens in the way, some of these light rays will enter the lens from points all over its surface. Okay, so the diagram shows that a tree at large distance from the convex lens will pass light rays into the lens. The convex lens can form an image of this tree, but upside down on a piece of paper. Okay, so basically, why it's upside down? I'm going to explain to you guys on the next diagram. Here are the next diagram. This diagram shows that each point on the object will reflect light rays onto the convex lens. Light from a point can meet at another point on a piece of paper on the other side of the convex lens. For every object, there are numerous rays being sent into the convex lens at many angles, but all these rays can become focused back into one image. So here are the reasons why the image forms are upside down.
So this is our references.